Hey everyone, Tommy from TechNexus, and thanks for joining me in today's video. Now, yesterday we covered architecture, and today I wanted to cover structure, but I think I'm going to break it up into two videos, one today and one tomorrow, because there is a little bit in the structure and steel portion of advanced steel, and the only reason I say that is because there's an option here for rebar in your concrete. So just sort of thinking about time, it'll be easier, I think, if I just break this up into two videos, and then at the end of the week we can cover systems, and then just a sort of a few of the other extra bits and pieces that we didn't sort of get into with the interface tour. Now, today with the structural model, I just loaded up the structural template. Just from the front, from the first page on Revit, the dashboard, and like I did yesterday with architecture, I'm just going to throw a couple of grids in. So just put in 1, 2, and then just adjust the length or the spacing between them, and then do a third one, and I'll just place it automatically at 10 meters. Close enough. Change it to 10. Oh. Make it 10,000. Okay, and then I'll do the same in the other direction. So 4 down to 10, and then one more. Okay, so this is just going to be the basis for me laying out my structure. Now I'm on level 2, so if I switch to level 1, so I'm one level down, and then if I look at my elevations, I can see that I've got 3 meters between level 1 and level 2. So I'll just adjust these level markers. Okay, now similar to, same I guess really as we have in the architectural sense, in the structural sense, we work on a level, and then we work out, we can constrain the steel member to a height. So I'm just going to stick in a structural column, and rather than do concrete, I'm going to do UC. So the one that's already loaded is a 310 UC 96.8, and I'm just going to stick it at the intersection of all of these grids. And you can see that it's got a depth uncontrolled to 2.5 meters, and I'll show you what we can do with that if you need to go back and change it. So we can pick that, and again, like yesterday, I can constrain it to level 2 and click apply, and then you can see that that beam is now, there's no offset on it, and it's constrained to level 2. So if I change this to be 4 meters, then again the column there is going to change to 4 meters. So we'll do the same thing for the other two. Constrain it to level 2, and then keep our offset back to 0. Okay, and then if I look at 3D view, you can see there we've got those columns. So I'll do the same thing for the others. Go column, but this time let's place one in the middle, and we want to go to a height, and I can lock that in now as I place it. So I can place all of these around going up to level 2. Okay, and again, if I switch to 3D mode, you can see there that I've just done the same thing, but by forcing that constraint when I do place the elements there as well. Okay, now looking at level 1, I don't want any beams on level 1, but I want them on level 2. So I switch to level 2, and then I click on the beam icon, and I'm going to do 310. I'll just leave the defaults, and I'm placing it on level 2, and then I can just snap between all of my members there. Okay, now you'll see that it's quite simple in its view. That also comes back down to the detail level. So I'll switch it to fine. You can see we get all of those members in there, and then if we switch to shaded, you're going to see what it looks like. And we'll do the same for the 3D view in fine mode, and we'll do it in realistic. That's a bit too dark. Let's go shaded. There we go. Okay, so there's our members there that we've placed, and I can do the same for the rest of them. I can copy these down to each grid, or just redraw them. So again, just redrawing them, just come back and just go through and snap and place to each one. Okay, I'll just do these ones for now. And again, switching to 3D view shows me what it's going to look like. Now, if you weren't already aware, we can put connections on here. So under the structure tab, and probably about 5 or 6 icons over, there's a button here called structural connections. So what you'll need to do is look at the connection settings and then have a look at loading the connections that you want in this model. So I'm not really interested in loading all of them. So for now, I just want to scroll down and look for shear plate connections and go OK. All right, now to add a connection, select the 2 elements, switch back to structure and go connection. And it's going to place a generic connection in there. So we have it here listed in the properties. And then I can click on the pull down and click on shear plate. And then what Revit is going to do is going to change that to be a shear plate connection. Okay, let me just switch around. Should be able to see it in level 2 there. So if I switch to wireframe, you can see there's that connection. And if I go to 3D, it's a bit, there we go. So you can see there, let me switch it to hidden line. There it is. Okay, so if I switch back around, should be able to see the bolts and everything in there as well. So to do the same thing with this other beam, so select the 2, structure, connection, and then do a shear plate, and we've got it all in there. Okay, now for the people following at home, if you are working with a steel detailer or you want to send this information out to Advanced Steel, so I've got Advanced Steel running here and I've saved the file just to save some time. I'm just going to save this first to my desktop, and I'm just going to give it a name, Revit structure. And you'll need to download and install the Advanced Steel extension from the Autodesk App Store. So you'll need to sign into that, download it, install it, and you'll get this button here. So just to go through some of these settings, I can export out the whole model, I can import a whole model, and I can synchronize. If you're going to be going back and forth from Revit to Advanced Steel, you'll need to do synchronize. The settings button here, so we can export based on view settings, grids, and ignore beam cutbacks. We can add paths for the libraries. Okay, and I just need to generate that index there. Ultimately, what will happen is we're going to export out from here, and in Advanced Steel, we're going to do an import from over here. So under the Export Import tab, we can import a Revit file, we can export out to a Revit file, and we can sync. So again, if I send my Advanced Steel model back to Revit and I make changes and I export another SMLX file, I need to synchronize that file, I don't import. I've also got under here Advanced Export and Import, similar sort of functionality, same basically. So we can just do the SMLX file there. Okay, so to do that, I go to my Advanced Steel extension, I export it. I'm doing an advanced export, and the country library is Australia, and put it on my desktop. give it a few seconds, and it's done. The SMLX file is a file type created by Autodesk for the conversion of Revit to Advanced Steel. It's essentially a packaged kind of XML file. If you look at it through Notepad, you can't really read or see anything. You can extract the files inside it, but there's no need to. You just let the software do it. So now I'm just going to zoom out of here a little bit, and I'm going to import, look for that XML file, and if need be, it will ask you for mapping these objects if it can't find a mapping table to go between Revit and Advanced Steel. You should be okay. They have done a lot of progress with that, but if need be, if you're coming from Plant to Advanced Steel, you'll have the mapping table that it might ask you for options there too. Now, I'm just going to save this. Let's say you get to the steel detailing stage and you need to change this. So we can pick this plate, go to the joint properties, and I'm going to go in the horizontal bolts. I'm going to put 3 in there just so we can see that there's been a change. Okay, I'm going to save it, run the numbering system. So I'm just going to run it with the SP number there. Yep. Save it again, and then go to export, and I'm going to export out to an SMLX file again. And then back inside Revit, I'm going to zoom to this connection, and now I'm going to synchronize that connection, or that model. Okay, so the connection's changed and the type has changed there. You can say yes or no to whichever one you want. I'm just going to say yes to all, and you'll see that that bolt set has changed in there as well. Okay, so there's the functionality between Revit and Advanced Steel. So other functionality, you've got walls in here as well, but again, structural and architectural, columns, any other structural floors. So let's go to level 1, and I'm going to put a structural floor in, and let's offset it 300 mil, and then click on the rectangle option, and then snap between the 2 rectangular points there and go OK. Okay, so again, there's that offset didn't stick, but regardless, there's our generic floor that you can change into I don't know, what do we want to do? A concrete domestic at 425. Okay, so now we can get all of the options that we want to see with the data for that. We've got structural trusses, there's bracing, and there's beam systems, and like I said, the connections are in there as well. I'm not going to go through the foundations or slabs or rebar today, so I'll go through that tomorrow. And also there are some options in here of structural connections, so you can do the connections from here, any fabrication items, so plates, bolts and welds, a little bit of modifiers, and some parametric cuts as well. So if you are going to get into the structural side of things, if you're a steel detailer, it's probably best to stay with Advanced Steel and export it out to Revit if someone needs it. There's nothing stopping you, I guess, from starting in Revit really if you wanted to, but you will have to determine at the beginning of the job whether you're going to do Revit or Advanced Steel for steel detailing, because Revit isn't going to populate assemblies of these columns. It's not going to do single parts of the plates, whereas with Advanced Steel, the reason I'm going to use Advanced Steel is because I want to generate A3 drawings of all of my single parts just by clicking a button. Okay, and then the same thing can happen for my assemblies. So once that's done, it's creating all the single part drawings. I can do the same thing with my assembly, so I can say all MPs. And Advanced Steel has created those files in the same directory that this model is in. And they're all individual AutoCAD files, and I can click on one of them and say, show me the assembly detail, and then there's that assembly detail as well. So obviously I need to clean it up, but regardless, it's showing me what that connection looks like with all of the welds and etc., etc. Whereas Revit doesn't. So if I need to, under my view, I could maybe create a section sort of looking through. Well, let's do it. Okay, and then if I move this, looking at that section, so now I've got that there, and I can just switch it to fine mode, and I can see that view there, but it's not going to give me single part drawings like it does with advanced steel. So again, you have to think about what you want to use this for. Yeah, just take each project as it comes and determine what your workflow is going to be, whether you start in Revit or start in advanced steel and need to export back and forth. Okay. So for tomorrow, I'm going to go through the foundations and slabs, and then start looking at the rebar and area and that sort of stuff for the concrete side of things. And then that should take us to the end of the week, where we're going to look at the systems, what you can do with that as well. So like every day, hopefully it's been informative for you. Thumbs up if you liked the video, thumbs down if you didn't, but please do subscribe to the channel and click on the bell icon for daily notifications of all of my videos. And I will see you tomorrow for some more structural workflows and modeling inside Revit. See you later.